Hi, welcome back to my video. Today we're going to take a look at a few integrals. One being this integral right here in front of us, e to the x sine of 2x. And this we're going to be using a skill called integration by parts. In integration by parts, the integral follows the following pattern. U times dv, and when we integrate it, we would get u times v minus the integral of v du. Now, how does this work? Very simple. Notice we're multiplying two functions together, e to the x times the sine of 2x. No other integration technique that we've learned so far works. Arc trigs, use substitution, none of them kind of follow this pattern. So I'm going to try this integration by parts rule. What we're going to do is we have to pick one of these, or we're going to pick each one of these to match up with inside my rule for the integral. One's going to have to be u, the other one's going to have to be dv. Now, under a normal integration by parts, it's pretty simple. Check out my earlier videos. I do a bunch like that, and I give you some hints. But if we have two transcendental functions, which is what we have here. This is two transcendental functions. It's a little bit trickier. So what we're going to do is we are going to pick one of the functions to be u and the other one to be dv. Now, which one do we pick for which? It really doesn't matter if we're dealing with two transcendental functions. Remember, transcendental functions are your exponentials, your logs, your trig functions. It doesn't really matter if we're dealing with two transcendental functions. However, I will say this. It is easier to take the antiderivative of e to the x versus sine of 2x. Sine of 2x requires u substitution. And I want to avoid that if I can. So I'm going to let dv be e to the x. And as always, we'll attach the dx to that. Now, that's going to leave us with u. Well, u is going to be the sine of 2x. And so I have u and I have dv. Now I need to find the following. Well, I have u. I'm going to need du, the derivative of u. And that's easy to do. The derivative of u would be, well, what's the derivative of sine? Would be cosine 2x times 2 dx. There's our cosine. And there's our derivative. Next, what we need v. Well, this is a little bit trickier. To get v, we look at dv. I have to integrate this. And when I integrate this, we get e to the x. And there's my rule. Now, I'm going to apply my rule. uv minus the antiderivative of v du. And when we do this, u times v, we get e to the x sine 2x minus the antiderivative of v times du. Now, I am going to lose your mind. There's a 2 here, it's a constant. It gets confusing with constants on these, so I just like to factor them outside my integral. 2, and I'm left with e to the x cosine 2x dx. Now notice I wrote this in a particular way. I wrote in the same pattern, my exponential and my trig function. That's to keep it kind of simple for me. But if you notice, we're going to have to do it again. I don't know the antiderivative of e to the x cosine of 2x. So I'm going to have to do my integration by parts again. So I'm going to let u now equal, again, e to the, my cosine of 2x this time. My dv is going to be my e to the x. We typically put the dx with there because I'm going to have to integrate it. So to get du, be careful, this becomes negative sine of 2x, again, times 2, chain rule, don't forget the 2 there, and dx. v is still e to the x. All right. Now, I'm kind of running out of room here, so I'm going to bend down just a little bit. So when I write this out, my new integral, I'm going to keep this e to the x sine 2x minus 2, but now I'm using my integration by parts again here. I put a big bracket here, and this is going to be u times v, or v times u, e to the x, cosine 2x, minus the antiderivative, v times du. But notice we got this negative 2 out here. We have to factor, plus 2. Easy, right? Times, and the leftover e to the x, that's an e to the x, times the sine of 2x dx. All right. I'm going to clean this up by distributing that negative 2. And I get the following. E to the x sine 2x minus 2e to the x cosine 2x minus 4 times the integral e to the x sine 2x dx. All right. Here we go. This is my integral. But you notice, at the beginning, we had e to the x sine of 2x. When we integrated the first time, we got e to the x cosine of 2x. I had to integrate again because I don't know that antiderivative. But notice what we're down here to. We're back to e to the x sine of 2x. I have to do this again, but we don't. Notice we're trying to evaluate what this integral equals. I've cycled back to the original. If I keep doing this integration by parts, I'm going to get the same thing over and over and over again. And we want to avoid that. We don't want to do that. That just makes it too tough. But remember, this is my answer. So what I can do is I can now set my new integral here equal to the original. And I've ran out of room, so I'm going to erase this a little bit. So what I can do now is I can set my original integral equal to what I have here. And this is going to become e to the x sine 2x minus 2e to the x cosine 2x. And that's going to be minus 4 times my integral again, e to the x sine 2x dx. Oh, look at the length of that. But we're in luck because since these are equal to each other, I can use a bit of algebra. I have this integral minus 4 times this integral. I can add 4 and this integral together. And I'm going to add the same thing over here. Yeah, we can add integrals together. Why not? It's just an algebraic equation for us. And that's going to give us 5 of these integrals. Dx equal e to the x sine 2x minus 2e to the x cosine 2x plus c. I'm going to go and put my plus c in there right now so I don't forget it later. Now, I'm almost done. Almost done. Solving for the integral now, I'm now just going to divide everything by 5. Those cancel, and I'm left with my antiderivative. And there it is. The world's longest, well, second longest antiderivative for BC calculus. I hope you enjoyed the video. Please smash that like button. All right, you guys have a great day.